Alright, this is part 2 of the volume control. Now, in the back, I showed you on the last video, there's a Y-shaped connector that goes under the hub. And the springiness for the mechanism comes from the other side, from the two wiper arms that press down on the resistive thing, so the resistive pad or track that you want to call it. Now, I took this pin vise and I drilled out the rivet that held the little contact, and you pull it out after you get rid of the rivet. Very tiny stuff here. Now, I'm not afraid of stuff that's small because I've actually worked on watches. But you can see, this is the contact. See how dirty it is? Okay? That black stuff is oxide. And the hub, let's push the hub out to the other side. This is a steel hub, sticks to a magnet. Alright, let's see if we got in the frame. And it's got two arms that touch the resistive track. And one of them's bent more than the other. So that's telling me it's possible this volume control hasn't worked from day one, because the radio sold to me was in the original box in mint condition. So I got a feeling that when the person got this, put a battery in it, turned it on, the volume control wasn't making contact, because when it was made, it wasn't made correctly. One of these arms would be the wiper. One of the wiper arms. There's two wiper arms. One has more tension on it than the other. Okay, that's the first possible problem. Then this is all oxidized, and the steel hub, the slot where the arm rides in, that's all messed up. But that could have happened from it sitting all those years. The other thing too is this little connection, when it sits in there, should have a little bit of upward tension on it. And it didn't have any compared with this one that I looked at. Okay, so this is doable. You can take this apart. I can clean this with an eraser. Remember I told you, you clean the pieces with an ink eraser. All right, and then put it back together. Now in this case, I drilled the head of a rivet out, miniature rivet, and if it's still there, let's see if it's still sitting there. Yeah, I can put this back over the river and solder it, but I might make a new rivet. I can make rivets, I've done it before, but when I put this back together, each part is going to be cleaned, inspected, and I'm going to make both these wiper arms have the same amount of tension. And then I'm going to give this a little bit of upward pressure. So when it rides in this little a little groove, or not a groove, what would I call it? Well, anyway, it rides inside of like a T, but it's round. I can't even describe it. But anyway, I'm going to make this have a little bit of upward pressure, because the other side, this pushes away. So it'll add to this, but you could actually see that this Y slip ring wasn't, that's what you actually call that part, a slip ring. When it rides in this slip ring hole, okay, there was no upward pressure. And that slip ring is all dirty. I'm looking at it now, it's black. And that's steel. Like I said, it sticks to a magnet. Okay? And it's possible just a production problem, or this radio just was never used and the parts in the switch oxidized and then wouldn't make contact, and you basically got a bad volume control. And when you moved it up and down the volume control, there were places where it would touch and the radio would work, and that's really annoying. Okay, and that's what they do when they go bad. But if you look inside this and you look at that ring, that resistive ring, and it's on a piece of Bakelite, and it's riveted in there too on each end. And I've seen that where that resistive ring in there gets broken in half, and that's from something that's been dropped. But this doesn't show any of that. This is a new problem that I've never seen before. And I told you on the last video, if the resistive track wears away, you take a number 2 pencil and you recoat it. You repaint it would be carbon. A pencil isn't lead, it's carbon. But anyway, there's another name for the carbon. Oh, brother, it sucks getting old. It's not lead. It's carbon of some sort. But anyway, you know, when you get old, you can't recall all the words, senior moments. But that's what you do. And you make sure the pencil's not sharp either when you're painting it back in. And you can get the radio to work, and then hopefully you can order one of these. Now, I ordered 5 from the UK. The order is all screwed up. I have no clue, even if it's real. I bought it on one of these places that sell stuff like eBay, but it's in the UK. So I don't know. One of the vendors. And then her name is Female Joan. That's who sold it to me. She's supposed to have given me an email by now, but you know, UK is out of they're out of sync with us by maybe 24 hours or something like that. So I'll give it time. But it would be nice to have a few of these volume controls. But now I'm at this point for in the future, I won't be afraid to take one apart and actually figure out why it doesn't work. But like I said, in the past, it's usually the carbon track in there. And what the hell is the lead in the pencil called? It's not carbon. Graphite, that's it. Okay, graphite, I got it. I hate when that happens. But in other words, you recode it, and it lasts a while. My one transistor radio, that holiday I showed you, I was doing that all the time, opening it up, recoding it. And I used that radio a lot. And it got to be annoying because the one night when you're using it, you realize you're going to have to open it up again and redo the carbon with the graphite pencil. You know, pencils are graphite, they're not lead. I don't know if they originally did use lead in pencils, but there's an old saying I used to kid people. You can lead a horse to water, but a pencil has to be lead, if you get that joke. Okay. I think that's it. You know, this is one of those videos for people that really get frustrated and they like to fix stuff. And I told you, there's a little Jesus clip on the back. It's a C-clip. And that holds the little snap thing for working the switch. And the reason they call this is a Jesus clip. When you lose it, you're going to be using Jesus' name. And then when you really want it, you're going to be praying to Jesus that you'll be able to find it. But that clips on the switch, and you got to make sure you're in sync in the right position, because this can go out 180 out. So when the switch is supposed to be off, it's still on. So when you put this all back together, it's not as simple as you think it's going to be. But in my case, I'm going to try maybe soldering to this part back onto the rivet, or popping the rivet out gently and making a new one. And I don't know if you've ever made a rivet from scratch before, but that's another thing you might want to learn how to do, is learn how to make rivets. Because there are things in this world that use rivets, okay? And you can get really fancy. And especially if you've got a lathe, you can really make some really fancy rivets on clothing and stuff like that, copper rivets and things like that. I want to, by past videos, I showed you one of my rivet boxes. These are mostly aluminum rivets. There are some brass, okay? And my dad showed me one time how to make a rivet out of a nail. And, you know, you cut the nail off and then you have to counter drill it back into the shaft of the nail. And you got to have it figured out when you roll it over. First you use a punch, and then you start it rolling over, and then you use a little miniature ball peen hammer, depending on how big the rivet is, okay? And there's a way to slowly roll that edge over. And, you know, he showed me, and I started making rivets on a lot of things. I think it was a 4x5 camera, or 4x6. I made a camera, and I bought an old camera, and I made a back for it so you could use plate film plate film. What's called plate film? Single sheet of film, and to make it really nice, and it made it look really good, and I had the felt in there and all that. I had to make custom rivets that were really shallow. You couldn't use bolts. You had to have clearance. So I made some rivets out of those big aluminum rivets. I cut them back and re-drilled. Well, anyway, I've done a lot of riveting in my lifetime. And certain toys, old toys, they were put together with rivets. Okay, and I had experience with all that. Now, I want to tell you a quick story. You know, I always try to fix everything from scratch. You know, and one time we were fixing like Epson printers, the industrial Epson printers for banking systems. And we started getting these printers in, and the guys say after 15 minutes, the print head starts hunting up and down on the platinum. It goes, right to left. The print head just starts floating by itself, back and forth, back and forth. So they'd send the boards in, and I would leave them on for 2 or 3 hours, and wouldn't do it. And then I finally caught on. I said to my boss, call the guy up, have him send the whole thing in. I said, I suspect the motor. So they send it in, and I put the board first in the circuit board in my Golden Idol, which is my test bed, and it doesn't float. I put it in theirs. Within 3 minutes, it starts to float back and forth. And I said to Dave, my boss, I said, the motor is bad, and I'm going to open it up. And he's like, I can get you a new motor. But so he goes off with the part number. I open the motor up, and I did motor repair in McGraw-Edison, so no big deal. You mark the motor so it goes, the housing goes back the same way. You don't take the armature out of the magnets unless you're sure it's modern magnets. So anyway, I open it up, and I'm looking, and right away I saw what it is. At some point, they stopped using carbon magnets in motors. They started using this amalgamated stuff. I think it's amalgamated is the word, like a copper, and it gets caught between all the segments. You got segments of it's a commutator. In between, this stuff would gum up and it would short out. So when the brushes were across 2 contacts on the motor, it was also putting slight amount of current in those other windings because it was basically shorted with this copper material. So all you do is you take a razor blade or something and you scratch down in between each commutator segment, and this stuff comes out, put it back together, and it doesn't hunt. It's perfect. That's it. So I got the printer printed and I'm testing. I'm giving it like a 3-4 hour test. And the boss comes back, he goes, we're screwed. I go, what's the matter? I couldn't get the motor? He goes, it's not available. You got to buy a whole new printer. I said, well, I took the motor apart and I explained it to him, what it was. I said, it's good. We sent it back to the guy, and you put a DOA tag on it, and then if he gets any problem, he sends it back DOA, and then we get him a new printer. But that was fixed. So when I get them in, I'd automatically open the motor up and service it. I wouldn't oil it. I would just clean that commutator segments out and blow it out if there was anything in there. And that was the way. But I just want to tell you that story. Sometimes you actually have to fix something. You can't wait for the part. Now in this case, I ordered from the UK these volume controls. But what if they never come? Then I have a radio without a volume control. Okay? And like I said, when I was a young kid, there was nothing for me to take something like this apart, put it back together, because I didn't have the money to buy a new one. And I want to tell you about these volume controls. In 1975, there was 69 cents at Radio Shack. If you put it in the inflation meter, okay, it's $2.59, today's money. But to actually get one of these as a new old stock, a lot of people want 12 bucks for them. Okay, and I don't know what I bought. I put in 5, it checked me out, it says $44.90, whatever it is. And then when you see the receipt, it says 1. So I don't know if I'm going to get 1 or 5 or if they're ever going to come. But little by little, I've been thinking about this. I said, you know what? Let's rebuild it like the $6 Million Man. We have the technology. Let's rebuild it. And I'm also being very careful to look and say, maybe there's more than the oxide problem. The oxide could have come from it sitting in a drawer somewhere. And really, there's a tensioning problem. Like I said, one of these arms, the pivoting arm or the slip arm, or there's actually a name, the wiper. The wiper, one of them is actually higher than the other. And they're both supposed to have the same amount of tension on them. I think that's it. I hope you enjoy this. Probably one out of 10,000 people is going to say, that's pretty cool. But the rest of the people, they're like, why would you bother? Just put another one in. Well, you can't get them. Okay? And I guarantee you, when you buy different radios on eBay, they're going to have been sprayed, and you're going to get the radio, and you're going to have all kinds of problems. Okay? The ones I bought were so pathetically bad that they're all original. This one's the best one. It's in fairly good shape, but if you really look, you can see this bottom corner's broken. Anything on eBay, they make sure they take pictures of all the sides but where the broken part is. And then this one was like $5. And this one here, I can't even get it out of the stupid case. The leather case is all mildewed. See it? And this is a $5 radio. It's got all I don't know if they spilled something into this grill, or it's rusting. But this one does work, and it was just the 4 capacitors. That's what's very common on these transistor radios. Now, I know I watch Shango 66's videos, and he doesn't just shotgun it by changing all the capacitors. He goes through and troubleshoots. And now he bought this really good meter to check each capacitor, and it's like 200 bucks. I'm not putting $200 out to check the capacitors. I have 3 capacitance checkers I bought over the years, and none of them can really test an old capacitor that's dried out. It tells you got more capacitance than you should have, and that's telling you that's a fake number. Okay, that's not a real number, and that capacitor is bad. So you still have to do a little bit of interpolation. Now, I used to be able to take a capacitor out and put the ohm meter across it and hit it. You put it across and the ohm meter would jump up. Then you reverse the capacitor, hit it again, it would jump up. And you do a good one, and then you do the capacitor you think is bad. And you'd see the meter doesn't jump up as fast or as high as with a good capacitor. That's how I used to check capacitors. And then over the years, I bought cap checker. And then at work, we would realize that they were getting fooled by certain types of capacitors that were actually bad. And then the other annoying thing at work, because we have idiots, they would check a 50,000 microfarad capacitor from a power supply without discharging it. And they put it across the cap checker and burn it out, and then it had to go out. So most of the time, you couldn't find the cap checker at work, or it was burnt out. Okay, I worked with people that constantly made the same mistake over and over again. It's like first day, first minute, first hour type of thing. We have people, you could put them on a job, and we had this one guy, you sit him down on the job, and you say, when you get this board in, look at the date, and if it's older than 6 months, change this capacitor. Don't troubleshoot it until you change that capacitor at a certain date. He wouldn't do that. He'd troubleshoot. Then he'd call over, he needed help. And like one guy would come over and ball the crap out of him, which you're not supposed to do, but he would do it. He'd call the guy an idiot and all kinds of nasty names. When are you going to learn? This is like the 10th time I come over here. What did I tell you about the capacitor the first day? And that guy was just terrible. And the company promoted him out to get rid of him, okay? And where he went to, they sent him to another company to like log in repairs that we were doing. And he got in trouble for chasing the women in that building. He was married, but he was a screw up from day one. But there are people that never learn their job. They never get really good at it. They don't really understand what they're doing. If you show certain people a circuit board, and I won't mention the different schools, okay? I think they're all out. There was Retz. I went to Retz. There was RCA school, and it was Bell and Howell. And some of these Bell and Howell guys, they were real good in theory, but practicality, like if they saw you troubleshoot a board to show them, and you changed a certain chip, every time they picked that board up, they'd change that chip first. And a lot of times they put it in backwards, okay? There was no getting the scope out and understanding what they learned. But if you put a test in front of them, they would beat you on the test. That's what amazed me about some people. They're book smart, but not street smart, okay? And you'll never learn. You'll never win. Like if I sit in the classroom with people and they teach us about a new system, it takes me a little while to get really good at it. But these people can answer questions incorrectly. And I'm sitting there, my head's exploding, and you know, all these different terms and stuff. And they know it all for a couple of weeks until after the test is over, and then they forget everything. When I actually learn something, it's mine forever. And that's just the way my brain works. And my brain is very reluctant to learn certain things. It shuts down. It gets tired. It makes me start yawning. But when my brain likes something, it soaks it up like a sponge. And that's why I got really good in electronics. I really love it. And I always, like I said, this is stupid volume control. 69 cents in 1975. But if you want to restore a radio, what are you going to do now? Do you understand that this side, the resistive track could be all chewed up and you got to recode it with a pencil? Could it be a bad connection on the back? You know, are you going to take it apart and clean it all up, put it back together? What are you going to do? You know, well, I just need the switch. Well, put it back in the box and put it in the closet and keep telling yourself you're going to locate the switch. Okay? Because that's what most people do. Okay? I told you, I was the guy that when somebody handed something to me and said they wanted it repaired, I'd make sure they really wanted it repaired. And then it would get done. And it wasn't always easy. You know, I had one radio one time. Guy gives me the radio. The output transistor is blown out, and so is a fusible resistor. And the fusible resistor said 100 on it. And it was a bell fuse. It was a big white thing that said 100 on it, and it measured 100 ohms. And when I changed the output transistor, the radio worked, but it wasn't loud. So I rebuilt the circuit based on one of my father's books, and I narrowed it down to that white block by Bell Fuse. Now I knew Bell Fuse was a fuse because at the place I worked, we made the insides for Bell fuses. It was a little piece of coil of wire, and then you put this like firecracker material in there that was wet, and then it would dry, and that would get mounted inside this block of like ceramic. And when too much current would go through, that firecracker type material would burn, and it would burn away the fuse, and that was what Bell Fuse was. But when mine burnt away, or the guy's radio burnt away, it went to 100 ohms exactly, and it said 100 on it, which was the part number. And then I had to figure that out, and trust me, that was not easy. I wired that whole circuit, audio circuit, up on a breadboard, and went based on this schematic book. And I realized in the book that block was 0.1, so I put 0.1 in for temper, and the volume come up. And then I went in and checked the current on the transistor, and it was all correct. And I realized that that 100 was a part number. It wasn't the resistance, but the resistance when it went bad was 100. That's the stuff when you're in long enough in repair, you get hit with, and you don't have schematics. Most of the time when you repair stuff, you don't have schematics, and the old timers called them a road map. And road maps originally were like $3.49, and at the end I think they were like 18 bucks. And the electronic barn would actually rent schematics to you. And I thought that was hilarious. And they said to me, John, some of these packages are 30-something dollars. And the people that are doing repairs, they can't afford that. You know, I'm like, holy mackerel. So people would come in the electronic barn, and they were like Sam's and then Ryder and Sam's. Well, anyway, they would go out with what we used to call the road map. And if you can't get that for the thing you're working on, you can be really good and still, like I said, I saw 100 on the resistor, fusible link, fusible resistor. It said Bell Fuse or something like that on it. I'm like, okay, it's a fusible resistor. And it burnt away, but it stopped at 100. Instead of opening up, and I had the radio work, but it just wasn't loud enough. Oh, and part of the story is, as I had the radio for repair, the guy got in a car accident, and he says, I don't need the radio back yet, they're fixing the car. Well, they took the fender off the car, they took the antenna that was on the fender, and they dropped it down in the back and behind the fender. They put the fender on top. So when I went to put a new antenna on the car, I couldn't get the wire through the firewall through that because I left the old wire in there. So we ended up putting the antenna further out on the car, which bothered me because when you go through inspection, you might fail. But the kid had another accident, totaled the car out like right after that. And he never did pay me for fixing the radio. But that's the way it goes, okay? I think that's it. All right, that's it.